slash teacher for Team 701. With me is Tony Mendoza, our design lead. And we're going to talk to you about Onshape, which is CAD software that, come on in, no worries. CAD software that was out in the kit of parts a couple years ago. It's actually been around for longer than that. And we'll talk about some of the features about it, why it's cool, and why we're using it going forward.
So actually,
see, because you clicked into a different thing.
Oh, damn. Okay.
All right, so we're going to start off with a quick little survey. Who's using Inventor? Hands up. Okay, handful of you. What year? 2019. Okay, so you got the most recent update. Who's on SolidWorks? Okay, handful of you. Most recent? You got no. What year? 2018. Okay. What about you? 2019. Okay. Anybody on something older than 2018? No. Okay. 2018. Those of you who didn't raise your hand, what CAD are you using? Fusion 360. Okay. Onshape. Got a couple of you in here. All right. So one of the reasons that I started pushing Onshape within my teams, I was at 5496 before this, is, can you still see me in the camera? Okay. Is that we were school district teams. We have school district computers, which means we have school district IT support, which is sometimes really great, but more often than not, they don't come and do updates for you very often. So I was actually running Inventor 2016 with my team last year. Good stuff, right? 2016, which is not great. So if you want, here's a bit.ly link and a QR code that you can scan. It takes you to a Google Drive folder, has the link to our Onshape document, my email, Tony's email, as well as this slideshow. So you can follow up with it later on if you so choose. I'll leave that up there for a second. All right, so what is Onshape? A handful of you already know you're using Onshape for your software already. Here's some of the best features. Onshape is like Google Docs. It's really collaborative. It's online. It has the ability to add comments, edits, multiple people working on the same stuff all at the same time. Collaborative. It's, most importantly, right, it's free. You don't have to pay for it. If you're a student or an FRC team, they have plans that you pay for, but we don't pay for CAD software in FRC. It's not worth it. Automatically updated every 3 weeks. Every 3 weeks. 2016 Inventor to 3-week updates. Building this presentation, we started a couple weeks ago, or a couple months ago. Onshape has updated 4 times since I started. Hardware agnostic. You can grab the Onshape app and run Onshape on your cell phone. Any phone, iPhone, Apple, doesn't matter. You can run it on a Chromebook. I'll demo it off of my personal Chromebook, which is like 4 years old. Works fine. It works on Macs, it works on Linux, it works on PC. Anything that you have Chrome or Firefox, you're able to get that, and you're automatically on the most recent version. No IT support required, no updates required. Some things that Onshape isn't by default. It's not CAM software. So if you're running a lot of toolpathing or CNCing, you have to find workarounds. It doesn't do finite element analysis by default. You have to run your own FEA processes outside of that. Doesn't render, right? So all those things that you kind of got used to being built into Inventor or SolidWorks, those are all add-ons that are in there, but they get packaged up nicely. They're not packaged up nicely in Onshape. You have to find them separately. And it's not offline, right? So if you are not online, you cannot use our online CAD software. It's CAD, right? It's CAD. Everything else is available as an add-on. Those add-ons are not always free. You have to go find that vendor and ask them for a sponsorship, etc. We're going to run through, there's 7 main things that we're going to talk about today. Start with parts and part studios, work our way through assemblies, drawings, sharing and collaboration, which is a big one, a sample workflow that we use on our team, some more of the advanced features of Onshape, including branching and merging, which is something that they grabbed from the software world. Parts and part studios. So again, another QR code and link. That's in that main folder. This just takes you directly to the Onshape document. If you want to follow along and you have a computer, you can do that. If you try and grab it on your phone, it's 50-50 whether or not it'll work. All right. So one of the things that's unique or cool about Onshape is along the bottom, you see kind of your standard workflow that you'll have in different CAD packages. You build all your separate parts, and then you come down and you assemble them. And Onshape uses something called part studios. You still end up with unique separate parts, but you build them in one big container file called a studio. And that gives you some advantages as far as parts that relate to each other. When you build holes that go in your parts and you want them all to line up, you don't have to add that geometry separately. You just run it through all of those parts in one shot. And so Tony's going to pull up Onshape right now, and we'll actually look at a part studio, and we'll talk through some of the features of CAD, some CAD features that you're used to seeing. So here's our Onshape. If you followed the link, this is there. You can see right along the top, you got your 4 foundational features, your extrusions, revolves, sweeps, and lofts, those things that you're used to seeing. If we start a sketch, all those sketching tools are available to you as well. Same thing that you're used to seeing. Nothing here is different at this phase. What is unique is, go ahead and close out of that sketch and zoom out, Tony. 1, 2, 3, 4, 5 parts in this part studio that are all interlinked and joined together. And so Tony actually built this with the idea of making some modifications in mind. And so he got some variables he programmed in, but if you just change these manually, it would do the same thing. So we're going to switch out some different things. And you can see how this gearbox changes and everything adjusts all on its own together. Doing this way instead of in an assembly gives you some performance benefits because you're only calculating geometry. You're not calculating geometry and assembly constraints. Tony.
I should have done this a different way. Hold on. There you go. That makes it easier. It's not okay. There it is. Okay. So the first thing I'm going to do is I'm going to change the gear ratio of the gearbox. So I am changing. That's not good.
We lost your screen, Tony.
There you go. What? There you go. Okay, so I'm going to change the gear ratio from 42 to 48. 48 for the first driven gear. And as you can see, once it loads up all the changes, you're actually going to see, pay attention to changes in the actual gearbox plate. Because that's where they're going to be most evident compared to the previous version. There you go. So the first change is that all of these lightning holes, those holes cut out to make the gearbox lighter, they actually change to match the new gear ratio. And if we go into the assembly, you can see that the gears that I changed it to mesh up pretty nicely, and the gearbox matches to fit those gears. And if we go back to an assembly with the old gear ratio, you can see that the gearbox is now too big and the gears don't actually mesh together like they should. So that's just changing the gear ratio. I also can change the actual thickness of each gearbox plate. Let's go 1/2 inch. All right, so now we have some pretty thick gearbox plates. And one thing you'll notice is that the length of this shaft, the offset length from here to this face is the same no matter what configuration I put this gearbox in. I can change the thickness, I can change the gear ratio, I can change the actual spacing in between the plates. So let's go 5 inches just to see a more dramatic effect. See, you can see how the actual length of the spacer has changed based on what actually changed the dimensions between each gearbox plate. And yet, look at this shaft; it's still in the same offset distance from the front of the plate, basically.
One quick note: that's not our computer. That's not something we brought with us. That's not something we loaded up Onshape through a browser on a random school computer anywhere, and you can still do all this stuff. You can see how quick the updates happen. It's mostly dependent on your internet speed more than anything else. Graphics tessellation happens a little bit. The more better your video card is, the better it performs on big assemblies. But all this happens in the cloud.
Yeah, so I'm just gonna put it back to what it was before, at least in the thickness and plate thickness. And then you can see it goes back to the way it was before without anything in your, everything is edited in context. So none of the shafts broke, none of the spacers broke, and then everything was easily editable using Onshape and its part studios.
Next slide.
Next slide. Okay. I gotta find it.
So parts and part studios, right? A lot of that's the same. You do have those benefits of building the parts out uniquely within the context. Assemblies become a little bit simpler because if you build your parts together in your part studio and everything fits, then when you go and do your assembly, everything's going to fit because it's already built to fit in together. One of the benefits of doing it this way is your parts and part studios, you build all your static structures and your assemblies are only there to show motion. Another advantage to Onshape assemblies is that they happen with a single mate connector. Sometimes you can use two to make your life easier, but instead of building out different flushes and mates, et cetera, to try and do that, where when you change your geometry, now you have 3 different points of failure. Everything's based off one piece. They call it a mate connector, and they pop up pre-populated all over parts as you build them based on center of gravity or center geometric centers, corners, et cetera. But also you can drag and drop them, just create them anywhere you want. We'll pull up the assembly that we had built out. And one of the things you'll see is that some of this, yeah, you could have built it with an insert constraint. It's going to look similar. But the plates, actually everything in this, it's a gearbox. If you run over to my, or just keep running. We'll build out an assembly real quick in a second. But you can see, scroll down here, Tony, on the left side. Oh, yeah. Right. There's all these different single connectors. And let's go show one.
What's an easy one to show? Revolute.
Sure.
Oh, this one. That's for the bearing and the plate right there.
So it actually grabs and creates little geometric coordinate systems at those different points. You line up your X, Y, and Z axes. You can set constraints as far as how far they're allowed to move, which is another way you can use to orient them. Just give it a rotation angle that's between 200 and 200. It will rotate around to 200 degrees. So you can get things done with a single mate connector. It's really helpful because when you go through and you make changes, things don't break on you. Also, if you look, scroll up here, all these different parts that are McMaster parts, our screws, our nuts, etc. They're all grabbed out of a linked document. And if Tony clicks on one of those links, it pops up and it gives you the option of actually updating independently. So when you load up your assembly, you're not updating every single part and then trying to troubleshoot why the whole thing exploded and doesn't work anymore. You can grab each piece individually and choose when to update it, which version to release, and which one to keep back. So it lets you see your problems a little bit clearer because they're breaking individually instead of 10 pieces at once. Let's go back to our slides.
Here you go. This is not
Keep going.
good.
You're good.
I have like 5 tabs open. There you go. And then why is it? I know how to use slides, I swear.
Present, top right.
There you go. Okay. So
thanks. So, right, this is something we run into all the time. You change one part, you end up with 1,000 broken references that you then have to go through and troubleshoot. Not fun. Cuts down on those issues.
That's from last year's robot.
Last year was 2 years ago.
Oh, wait. No, that's 2 years ago.
2 years ago.
Yeah.
Okay.
Next slide.
Drawings. Our drawings. There's not much different here. Go next. You're going to see a lot of the same things you're going to do. Place your view, drop your dimensions. One of the cool things is that drawings are one of the things they're updating the most right now in Onshape. So if there's something there and you're like, oh, I really wish they did X, Y, Z, odds are it's in their ticket support, and they've had a drawing update every update for the last 10 updates, I think it is. So they keep adding features to help your life and to make your things simpler, and also features that people are asking for that are missing. We got a drawing demo where, again, right, you drop your view in. One thing that's a little different is because you have your part studios instead of just individual parts, you actually have the ability to make a drawing of your entire part studio or your parts out of that studio individually. Give it a second here for loading. Again, internet-based, right? So this is one of the cons. It does depend on your internet speed, does potentially have problems where if you lose connection, et cetera, et cetera. One other thing about drawings that I really enjoy personally is when you're putting something together, right? And your CAD team's over here and your mechanical team's over here in separate rooms or separate buildings, and you're working on stuff together, or you're at a competition and you're trying to find a dimension for something and you didn't bring the CAD computer, or your laptop's not working, you can pull it up on your phone. Grab the drawing, add a dimension to that drawing to see what you need. A couple years back, the first year I used Onshape, I had the field drawing in here. And so people were asking questions about field dimensions, and I was able to grab whatever dimensions I needed customized to what we were asking for.
Well, that's what it looks like in that small window.
Try reloading the whole thing.
Yeah, I mean, that's the second time, but okay.
Drawings are also one of the things that tend to be the slowest in Onshape. That's not where they push their performance enhancements yet. So, what? Rendering a bot, though, it's somewhat, you mean like actual photorealistic render?
Oh, there you go.
Yeah, it does. It takes a while. It's also, again, dependent on your hardware, right? If you have a CAD computer that's going to run any of your CAD programs faster because it's got the big graphics cards and a lot of RAM, it's going to work better here as well. So quick drawing out of there, and you got your dimensions, right? Everything places. It's all the same. Nothing here is really different or unique. It's one of the things we really like is that drawings aren't different. When I first started using Onshape 4 years ago, drawings actually were terrible. It was one of the things that hadn't started updating yet. Adding dimensions, you didn't have a smart dimension tool. You had to tell it in advance whether you're dimensioning point to point, line to line, arc tools, etc. And half the time it didn't work. So it's one of those benefits of the 3-week updates is that those things come out really quickly. You can see Tony's putting the whole part studio in here, or you can do, again, just an individual part.
There you go. Boom.
And again, that's just the static metal pieces. It's not the assembly.
Back to presentation.
Sharing and collaboration. This is where Onshape really shines. This is the benefits to Onshape. This is where Onshape is, in my opinion, the best CAD software that there's out there right now. It's for FRC applications. How many of you have mentors that can't come to every meeting, right? Or they have to show up really late and you're only there, they get off work at 5, you leave at 6, right? And so those mentors really want to help, but it's really hard when you see your mentor for an hour a week or something like that. Sharing and collaboration tools take that communication that you would have with the mentor and allows you to do it asynchronously. So you are able to do some work, leave comments, questions, etc. in your document that the mentor can see. They can log in separately on their free time and give you that design feedback about these things that you might want to change, tweak, etc. And you don't have to be in the same room at the same time. Kind of beneficial. We have a mentor that works for an aerospace company that last year we stopped our meetings at 5 and they got off work at 4:30. And she worked 30 minutes away. There was no way for her to actually come and interact with us except on weekends. So we were waiting until Saturday to ask all those questions. Now she gets off work, she can go home, log in. Tony can have a list of 3 or 4 things, questions that he's asked. And instead of screenshotting emails or shooting over files and emailing files that by the time she opens them have changed, it's a Google Doc link. It's the same concept. So when you open it, it's the live view of what's there at that time. Sharing and collaboration tools, if you go back to that first part studio, Tony, or the assembly actually. Assembly one.
This one's the one that works.
Assembly one, though.
Oh, okay. Oh, yeah, because it has the comment.
There's this option right here where you can leave comments. So if you click on that comment bubble, I left Tony a comment. That is not the right one.
Did you do it in the part studio?
Is it a different? Okay, well, Tony's going to add a comment here. So Tony has a design question, right? He's working, and so he can add a question right there, right-click on a feature that he's working on or a hole or something, add a comment to it. Go ahead and hit add. Rotate your view around, mess with your screen, right? Well, if you come back, there's this link embedded in Tony's comment that says edge of extrude, whatever. And if you click on that link, come in, Tony clicks on that link, or I come in and I click on that link separately, it will take me to the view that Tony was in when he had that question or made that comment. Zoom to the same level, rotated to the same level. There's no question of what piece am I looking at here. There's no need to take a screenshot, draw circles on it, mark it up. It's all right there directly involved. If he tabs out and goes to a different part of our Onshape document, it says, hey, this comment's not in this piece. You click on it, it takes you to the right part studio or assembly or whatever, and then you can click it again to get to that same view. So the collaboration tools help out there. Did you have a question? Yes. Yeah, so we're actually going to demo that in a second. I have my Chromebook here, and I'm going to log in, and Tony's going to be logged in, and you can see that we can make changes and edits all at the same time. And as long as they don't clash with each other, life is great. So Tony can edit one Gearbox plate, I can edit the other. Tony's actually going to follow me, which is another tool that you can use out of collaboration, which we're going to do right now, actually. So this is... This is my Chromebook. It's 4 years old. It is a Chromebook. It is not a powerhouse of hardware. And
so while he pulls that up, this is the sharing screen. So as you can see, that first line, it's shared to the team called 701. So that means Pochop and I can add anyone who's on our design team can access this document and any other document we create and share with the team. So that really helps with collaborative work. We also have a library in there where we pull up like different parts, like screws and stuff. That is all in that document. Yes.
Probably the existing library with all those parts already made?
Yes, there is for a lot actually.
There's a couple of different libraries out there. We don't have one that we've released, but I know a couple of FRC teams have. There's a standard content library from Onshape that has all your standard screws, nuts, etc. that are out there. There do exist those libraries out there.
FRC specific, there is. Do you want me to show them? Are you doing?
We'll come back to that in a second.
We'll come back to it later. Yeah. All right. So, are you in?
I should be. Yeah. Are you in the same document as I am?
Onshape presentation.
Let me see. I wonder if we don't have good enough internet. Let's see. So I'm on my Chromebook here, and we're gonna show. You're in the Part Studio demo.
Mm-hmm. Yeah.
Right.
Are you gonna edit something?
So I'm actually gonna make some edits here on my end. It's gonna reload. I think we're in different documents. That's a bummer. But it would actually make those changes on Tony's screen as well. You could see them.
How did that happen?
I'm not sure how that happened. It also could just be an internet lag issue where we're waiting on the update to come back down.
Oh, there you go.
There it is. The change shows up now. One benefit is you get infinite undo. So if we're in different branches.
What branch are you in?
The one that's at the top. Widget changes. Double click on it. There we go. Branching and merging. We'll talk about that at the end. But there are the ability to branch. If you click up here, Tony, on the versions history.
Oh, versions history. Oh.
Or
Well, now
that
I'm
works.
following
So
you.
Tony's following me right now. He's actually seeing my screen as I rotate my view around. He's seeing where my mouse is. He's seeing all the changes that I'm making. Again, you have that mentor who can't be there, right? They're home or they can't come on the weekend, and you have this question and they can log in and you can follow them. You can watch. How do you build this feature or this component that I'm struggling with? You can see them walk through the process. It's beneficial. Another thing, just leave the follow on, Tony. See if this works. No, it doesn't. Okay. Was there a question? Yeah.
I actually have a question. For teams that really need software capable of doing CAM for a machine, is it particularly difficult to find a workaround?
We're actually going to talk about our workflow that we use, which ends up in Fusion 360 for our CAM software. There's other ways, there's add-ons that you can get through Onshape that you're limited as far as number of parts per month you can run for most of them. So if you don't have a big need, come back here real quick. We'll look at versions for a second. So you get all these versions. There's some branches here that we'll talk about in a minute, but you can actually roll back all the way to the very start of this part and see what it looked like at the very beginning. You can roll back to version 2, which was when Tony decided, hey, I've got some stuff here that I want to be happy with. And you can see the differences in there. Hey, look, there's that part studio is still empty. If you click on H Gearbox parts, Tony, at the bottom.
Oh, yeah.
This is a part studio that he built, and then we accidentally actually got rid of because we decided it didn't help in this presentation. We changed it. And then if you come back to main or widget changes, either one, you'll see it comes up with that part studio doesn't exist anymore. We can't open that tab. So you have that versioning and that history. So if you, every time you go through your prototype stage, you get your next level of design, you create those versions. It makes it really easy to come back at the end and grab those pictures for your engineering notebook for the judges to show the process that you went through in your design. Next. File management, we just talked about. Next.
That's also from 2 years ago.
So production team. One of the things we run into is our CAD team works in one room. Our production teams work in another room where they don't necessarily talk. We end up printing out lots and lots of exploded views. And then the design team makes it like 3 changes that are very small, and we have to reprint lots and lots of exploded views. So by doing it this way, we end up very green. We save trees. You can have your design team, your mechanical team, actually just pull open changes on their phones. They can see the assemblies. Your exploded view, sometimes you can't really see a detail. They can open it up, rotate around, see everything they need to see right there on their phone, and it saves, makes their life a little bit easier. Next slide. So our current workflow, right? You were asking about CAM software. We do a lot of our own CNC machining, all those things. We do all of our CAD in Onshape. Create our parts, create our assemblies, create our drawings. Everything gets built there. And ultimately, the easiest way we've come up with is you drop out a step file of the parts that you want to CNC. And we take those to Fusion 360, load them up where we have all of our tooling set up, et cetera, for our Haas mills, and we run them that way. There are some add-ons that you can use, and we'll show you how to get to those in just a second, directly in Onshape that grab your part studios. The downside of this is if you make these changes here, you have to go through re-export and make those CAM changes again.
Right, so if you have a large assembly with a lot of different parts in it, and you only want to run CAM on one of them, so you would go into the part studio for that part, you would export the individual part studio as a step out. That's
just one part.
You can do that for just
Yep,
one part.
just an individual part. Tony, you want to pull back that part studio? Yep, we'll demo that right now. So here in the bottom, you can see there's a parts list here. You can also just right-click on any of those parts and export. You just export right there. You can export to all the different formats, STL, et cetera. You can export the full part studio if you wanted to as well, or Tony, hit cancel. Right-click on one of those gearbox plates. You can export it from there as well, so you don't have to go hunt it down in there. Yeah, great question. That's, again, that's our workflow. That's what we're doing right now. Coming back to that part studio for a second. Sorry, Tony.
Never mind.
All right. You'll notice down here in the bottom, there's a bunch of parts, and they're named part 1, part 2, part 3, part 4, part 5, which is the names that they come up with as you name them. One of them actually has a name. If you look in the assembly, right, in our model tree, we have part 2, part 3. Tony's going to open up the Bill of Materials Manager flyout off the right side of the screen. And you've got your bill of materials right there in your assembly, which is nice. And Tony's going to change the name of part 2. If you hover over it, it highlights it. That's all those spacers. He's going to call them the spacers. And he's going to go back to our Part Studio demo. And it's kind of hard to see. Sorry, this resolution's not great. It renamed it from part 2 to spacer in the Part Studio as well. So if you end up going all the way through, or you have multiple Part Studios where you're pulling parts together and you have 4 Part 1s and 5 Part 2s, you can grab them in your bill of materials and rename them there, and it'll propagate backwards as well. It's kind of nice. Next. Things that we like and dislike, right? We like the collaboration tools. It makes it really easy. It gets more of our students involved. We don't have a couple of designers who have their CAD software on their computers at home who go home and do all the work and then come back and they're like, look, this is great. It gives everybody a chance to contribute a little bit more. The multi-part studios are something we've been really enjoying as far as making sure all of our holes line up and brackets work together. The single connection assemblies are great, cuts down on errors, and the ability to pull it up on your phone is fantastic. Things that feel the same, right? Drawings, there's not really a difference. The basic features, extruding, all that stuff, it's the same. The help documentation is about the same. It's there. I think it's actually a little bit better, but my student said it's about the same as everything else. Things that we dislike, that we really are having a hard time working around. Doing exploded views requires a lot more work. It's not simple exploded clicks and buttons. You actually have to go through, make a new assembly basically, and offset all your connections with some values to explode it out. This is something that Onshape has basically said, yep, it's fine. They have a posted document that says, here's 3 methods you can use to get around it. Exploded views aren't something we're supporting at this point. So that's a downside, something that we don't like. Was there something else you had to add to dislikes?
I don't know. It's just, I guess, the internet part, but we already talked about that.
The internet part, right? If you lose your connection or power, you lose your internet, it's kind of a downside. Next. So we're going to talk a little bit about some advanced stuff. How are we doing on time? Anybody? Did they say when matches were starting again? 1:30. Okay, we got a little bit. So we're going to talk about some advanced stuff, and then we'll take Q&A here in about 5 minutes.
Okay.
So we talked about editing the BOM in the Part Studios. Configurations are another thing that you can do in pretty much every CAD software. It's kind of nice to be able to do them in Onshape. Tony's going to pull up a separate Part Studio I had made. Same gearbox. I just copied it. Configurations. Yep. And you can see there's this input up here at the top where if you have some parts that you want to change and you want them to change between specific values, or you can program variables. So I took these variables that he had made and I changed them into 3 distinct inputs: a default value, a thin gearbox plate, and a thick gearbox plate. And so now if he changes it to thin, everything changes down to 0.125. If he changes it to thick, all those change out to 3/8. It's just another thing that you can see. It's kind of helpful, beneficial. And that's really easy to build out. You just click on the flyout and adjust some things. Next is going to be Feature Studios, or FeatureScript. Onshape is built on a programming language called FeatureScript. Everything that they do, all their features, holes, extrusions, everything's in FeatureScript. You can write your own custom feature scripts. So if you look at this is something I wrote for this presentation. It took me about 1.5 hours, 2 hours from scratch. I have never written a feature script before. So that's kind of gives you an idea of how hard it is. And there's a motivation behind that where the linear pattern tool is great, right? It's a grid of holes, really nice. You end up like this. And then you have your CAM team, right? They go through and they say, hey, make all these holes. We're going to drill them out. They're all the same diameter, 1 button, 1 click. Your CNC team runs it. And you end up with 27 holes where you could have gotten by with 5. And one of 3 things happens. You have some screws that go in there, and your mechanical team's like, why are there all these holes in here? And then your part's weaker, and it breaks. This metal plate was fabricated at an event because the polycarbonate piece underneath of it cracked because of all the rivet holes that we put in it. Or you get a rookie, and the pneumatic rookie rivet gun comes over, chunk, fills all those holes up with rivets, and you have to make a change on something, and you have 27 rivets to drill out. Not fun. So one of the things that I did, the motivation behind this is we don't need 12 holes here. we could get by with 5 or less. So I built a custom feature script to kind of show the design team how well this works, where it just makes an X pattern with some spacing based on standards that we've come up with and within our team to create those. And so Tony's going to show how quick and easy it is to actually call on a feature script that you've made. So anybody on my team can access this. So it tells him what his inputs are needed, right? What parts you're going to cut. And if Tony goes and looks at the inside of that tube, and we're cutting through both parts, he selected both of them. If he deselects the aluminum 2x1 in the parts to cut list, it doesn't matter how big we make this hole. We can tell it it's 12 inches, 18 inches, 2 inches. It's only going to cut through the selected parts. So it'll skip parts that you don't select. It gets you a little bit easier way, and that's true in all Onshape part studios, to do through holes. So if you change the size of a part or the thickness of a part, you're not updating your hole sizes anymore. It still works and it doesn't cut through the other pieces. The last piece is branching and merging, which is something that if you have a programming team, they're familiar with this from GitHub. It's kind of advantageous. I haven't come up with a specific FRC example in my couple years of running Onshape teams that we've needed it for. So I grabbed the Onshape example. Our programming mentor last year, when we were demoing this for him, he said, hey, this stuck Git in your CAD. So the next slide here kind of shows what this is going to be. I grabbed this from the Learning Center on Onshape, which is a really cool help place. Walks you through step by step how to do different things. We'll show that in a second as well. So if we come back to our part studio, branching, merging demo, and come up to our versions list. So there's 2 versions here. There's widget changes and baseplate changes. If Tony selects baseplate changes, you can see this baseplate has some holes that get drilled in it for mounting. Widget changes changes the widget on top. And you can actually right-click on baseplate changes, Tony, and do compare. And it'll show you what's different between the 2 of them. And if you click on circular pattern 1, right here in the feature list, it pulls up and it'll show you the exact differences. So it's a really easy way to tell what's different in between your 2 pieces. Again, from the programming world, GitHub, you've seen this. And if you come back, hit escape, Tony. Waiting on the computer. Hold on.
Wait, what?
Not sure what happened to our input here.
Me neither. It just decided not to do it. I didn't do anything. It still recognizes it's plugged in.
Anyway, you can actually branch, or you can merge those back in as long as your features don't conflict. It takes care of that. So you have 2 different design teams working on 2 different elements that interact in some way, but they're not making changes to those parts together. They can make those parts in different branches and merge them back together for your final version. It's kind of helpful. Again, the Learning Center is what I want to show next, which is right here next to the App Store. We'll show that as well. Learning Center has all the Onshape learning pathways to talk you through what's different here, self-paced courses or technical briefings, either one, and it gives you all the different things that you are looking for. The other piece was, go back up to the App Store, Tony, and you were asking about CAM. There are simulation tools here. There's rendering services here. There's a visual CAM C here, right? That'll run your CAM profiles for you. A lot of these are cloud-connected apps where as you make changes to your Onshape Part Studios, it automatically updates in whatever those connected apps are. Downside, intact simulation, right? Stop scrolling, Tony. Free for your first 5 simulations. After that, it's not. It's also $60 a month if you want to do unlimited simulations. So your business team now has to go out and instead of SolidWorks sponsoring your team and giving you all those things packaged together in SolidWorks, you have to hunt down these different vendors and hope that they're going to sponsor you as well for those freebies. It's a downside. Questions? Who in here was using Onshape? Saw a couple of hands. Okay. What do you like the best about it? Those of you who are. It's simple, right? Anything else? It doesn't require a $1,500 computer. Yeah, it's really nice.
I can just kind of CAD at school whenever I have free time in a class.
Yeah, My first year using Onshape and FRC, I was with 5496, which the district had gone to Chromebooks for the entire school. Right? Chromebooks for the whole school, Vacaville. Which is great until you've got students who are trying to do CAD in their other classes when they finish work early or whatever. And now with Onshape, you can do it wherever. Quick shout out, 1678 set up all these workshops. They also streamed everything and did the recordings for us. They asked us to put this slide in. If you have feedback about the presentation, feedback about the schedule, anything like that, QR code, scan it, takes you to a Google form. You can fill that out, drop it in there. Do we have any questions from the live stream? We've not. Yeah. So we went from Inventor to Onshape. And actually, Tony, if you pull back up the Onshape preferences real quick, I want to show that as well. It's once you know one CAD software, it's really easy to transition to another one, right? I've been using CAD since 2005 when I was in college. And I started on a software called Pro Engineer. Which is no longer exists. Once you learn them, it's all the same. If you click on your name, and go to my account and preferences. But one of the things that I really like about Onshape that they've done is they actually make it really easy for you, right? One of the things that my students always complain about is I like my view manipulation a certain way, and it's not the way that they're used to. You can change it per user right here. So you have your Onshape settings, you can do SolidWorks settings, so you don't have to learn new keyboard shortcuts for view manipulation. You're coming from SolidWorks, so your S key shortcuts to pull up, you have that, and you can customize it. Scroll down a little farther. You can actually customize it, what pieces you want to pop up in your sketch for your shortcuts, what pieces show up for your extrusions, profiles, your drawings, etc. So it's really customizable, which I like a lot. It makes it really easy to make that transition. Yeah. Yes, actually, that's one thing I forgot to mention. Because it's online, it actually saves automatically every time you do something. There is no cloud crashes. There is no Control-S every time you do a feature or a change because you don't want to lose it. And again, that versions and histories Tony showed, you get basically infinite undo. It's just a giant database that Onshape houses on their servers. You want to roll back 5 steps, you can roll back 5 steps. You want to roll back 100 steps, you can roll back 100 steps. You're not limited by how big your undo file cache file is. You can undo whatever you want, which we really like. It's kind of nice to be able to test things out. And also it's really nice to, our computers at school shut off at 7. We stop meeting at 7. So you don't necessarily have to scramble to get that last save in before the computers shut themselves down. It's automatically saved and backed up. It's really nice. You have another question? Yeah.
When you were going through the gear ratios and adding in gear ratios, is that an imported part?
The gears were imported parts.
were imported.
The plates, the axles, everything you see in the part studio was not. Yeah.
So is there like a specific constraint designed for gear ratios?
Tony?
There actually is. There is this gear relation constraint in the assemblies, and you just have to select which mates you did. So if you used a Revolute mate, I'm just gonna go to one I already did. As you can see here, I had to click on the Revolute mate, which is the mate that makes the gears actually spin, and then you just put in the gear ratio basically. So it would be the first mate you clicked on over the number of teeth in the second gear that you click on. And then you just type it in as an equation, and then you can rotate the gears, and now they function like actual gears.
And can you use variables to eliminate the step where you have to manually type in the gear ratio?
I don't know if you can use variables on. I'm pretty sure the variables are only on Part Studios.
That's not something we've come up against yet, so I'm not sure.
Yeah.
Yeah, sorry. Wish I had an answer for you.
I mean, I can check variable. No, not on assemblies. It's only on your Part Studios.
Other questions? Cool. Awesome. Thank you, everybody, for showing up. I hope this was informative.